Hello everyone. Today we are going to start chapter number 19, Rocks Around and Inside Earth. We will read about rocks inside the earth. But before that, let me tell you, we have already learned about these things in our previous class. As you all know, we live in a dynamic environment. Dynamic means ever-changing environment where the different components are in constant interaction with each other. Like that, the interior of the earth is also in constant motion and undergoing massive changes over geological time scales. Most of them we are unable to feel these changes. However, on some occasions we felt these changes, such as during an earthquake or a volcano eruption. The earth's interior is made up of rocks of different densities and different chemical compositions. These rocks may be in solid or molten form, depending on the pressure and temperature at which they are. Let us learn more about that. So, rocks inside the earth. The earth's interior comprises three layers: crust, mantle, and core. In the previous class, you read about how the layers of the earth could be compared to an apple. The same, like the thin outer layer of the apple represents the crust, and the pulp can be compared to the mantle, and the hardened part inside the apple, that is compared to the solid core of the earth. Similarly, the density of the earth is the highest in the core and gradually and slowly reduces towards the crust. As we move from core to the crust, its density reduces slowly. In the process of forming and evaluation of the planets in the solar system, heavy metals such as iron sank to the center of the round planets and formed a densely packed core. The numerous lighter metals such as silica, aluminium and magnesium came to the surface and took millions of years to solidify into the thin crust. The intermediate, which is in the middle, that is mantle, metals remained in between and formed the metal. Let us now study these layers of the earth in detail. First is crust. You can see crust. The outermost layer of the earth is called crust. It covers the surface of our planet. It is the thinnest of all the layers. It is the thinnest one and makes up only 0.5% of the volume of the earth. The crust of the earth contains oceans as well as continents. It is the layer where we people live. The width of the crust can vary from 5 to 60 kilometers. The average width of the crust is 35 kilometers under the continents and 5 kilometers under the ocean floors. The continental crust is made up of silica and aluminium. The continental crust where we are living, it is known as Sial. It is known as Sial. It is made up of silica and aluminium. The continental crust consists of silicate rocks such as granite. The oceanic crust is made up of minerals such as silica and magnesium. So therefore it is known as seema. It mostly consists of basalt. Sial is lighter than seema because aluminium is lighter than magnesium. Next is mantle. This is a layer which just lies beneath the crust. It extends up to a depth of 2900 km below the crust. It is the center layer. It is in the middle. The mantle consists largely of iron, magnesium and silica in the form of molten rocks. It exists between a hot core and a colder crust. crust is colder and the core is hot, and it is between both of them. You can see same in the diagram. There is crust, then mantle, then core. This phenomenon has given rise to convection currents within the mantle. The colder rock mass in the upper region of the mantle continuously sinks to the bottom, and the lower hot mass of rocks just above the core travel upwards. This process is very slow and occurs over millions of years. These convection currents cause the mantle to be molten in form and provide motion to the plates in the crust. This is the layer where molten rocks are present. Next is core. It just lies beneath the mantle, and that layer is called core. It is divided into two parts, outer core and inner core, and it is made up of nickel and iron. That's why it is known as knife also. The other name of core is knife. The core of the earth is divided into two parts, inner solid core and liquid outer core. The outer core is 2300 km thick, and the inner core, that is the liquid part, is 1200 km thick. The temperature of the inner core can be as high as that of the surface of the sun. Next is rocks around us. There are different types of rocks around us. A rock is a natural solid mass made up of several minerals in various proportions. Rocks are of different colors, size and textures. Some are dense and compact, and some others are light with large pores, yet some others are heavy and they are with many tiny pores. So we can classify rocks into three major types: igneous rocks, sedimentary rocks and metamorphic rocks. First is igneous rocks. The word igneous comes from the Latin word ignis, means fire. During a volcanic eruption, the red molten magma comes out of the surface of the earth. Over time, it cools down and forms hard rocks. Because of their origin, these rocks are called igneous rocks or primary rocks. The molten magma that comes out on the surface of the earth is called lava. When that magma solidifies into hard rock, it may form very fine grained rocks or large grained rocks. On the basis of this, we can further classify igneous rocks as intrusive rocks and extrusive rocks. We can further classify into two different types: intrusive rocks and extrusive rocks. Rocks that formed by the rapid cooling of lava on the surface are known as extrusive igneous rocks, like basalt, light and porous pumice stone, and andesite rock found in the Andes are all examples of intrusive igneous rocks. However, when the magma is unable to come out on the surface and cools off slowly deep within the earth's crust, it forms large grained rocks, and these rocks are called intrusive igneous rocks. Granite is an example of an intrusive igneous rock. Next is sedimentary rocks. The word sedimentary comes from the Latin word sedimentum, which means to settle down. Rocks break down due to different types of weathering, and that weathering produces fine particles or sediments from the rock. These sediments are carried over long distances by the wind, water, rainfall and ice. These sediments then get deposited in layers one above the other. Over the time, the top layers compress the layers below, resulting it becomes hardened, and that layered form of sedimentary rock. Each layer is a great storehouse of historical processes, life forms, and environmental changes. Different layers of the sediments contain fossils from different plants, animals, and other microorganisms that once lived on the different layers at different times. Those have been discovered from many parts of the world. Sandstone is an example of sedimentary rock. It is formed from the grains of sand. Next is metamorphic rocks. Metamorphic means formed by the action of heat and pressure. The igneous rocks and sedimentary rocks under great heat and pressure change into metamorphic rocks. Metamorphic rocks are formed deep beneath the Earth's surface. These rocks in the upper region of the crust exert great pressure on the rocks that are in the lower region. This results in a change in the rocks. Sometimes changes in rocks are also caused by the action of moving tectonic plates and due to the heat generated by the hot molten magma that is traveling up to the surface. All these forces produce great pressure and temperature that result in changing the original rock into the metamorphic rock. There are some examples of metamorphic rocks like marble. Marble is a metamorphic rock. It is made up of limestone. The limestone crystal change into larger crystals and form marble. Similarly, clay changes into the metamorphic rock slate. Gneiss, sachit and quartzite are some more examples of metamorphic rocks. Next is rock cycle. We have seen how all types of rocks undergo changes into different forms. However, these transformations occur in a cyclic manner. The process of transformation of rocks from one type to another is known as rock cycle. Like when molten magma cools, it forms igneous rocks. When the igneous rocks undergo changes by weathering, they yield sediments. That sediments get deposited in layers one above the other by wind, rainfall or moving water. When the layers of the sediments press over each other, they produce sedimentary rocks. Then both igneous and sedimentary rocks under great heat and pressure changes into metamorphic rocks. These metamorphic rocks are present deep inside the Earth's crust, where high temperature result in the melting of these rocks to yield molten magma. And that molten magma then starts another cycle by forming igneous rocks. Means then that molten magma while the volcanic eruption comes out of on the surface of the earth and cools down and then create igneous rocks, and so like the same this cycle goes on. Next is rocks and minerals. All rocks are made up of several minerals. What are minerals? Minerals are naturally occurring substances which have a fixed chemical formula. There are about 4,000 unknown minerals on earth. Most minerals are components of two or three elements. Quartz is a mineral which is chemically known as silicon dioxide or SiO2. All minerals have a crystalline structure. These minerals are used for various purposes such as some are used as fuels, for example, coal, natural gas and petroleum. Some are used in industries such as iron, aluminium, uranium, etc. And some more are used in medicine, fertilizers and in ornaments. Next is rocks are life support system. Many rocks such as granite and marble are used in homes and buildings. They are dug from distant places and transported by using vast amount of fuel to our cities to make our surroundings look beautiful. Like clay and sandstone are used as bricks, and these bricks are prepared by heating such rocks. Granite is the most common rock used by school children in their daily lives. Graphite is used in the lead of pencils, which we use for writing. Especially the students use it in their daily life. Diamond and gold are minerals used in making ornaments. Both these minerals are lustrous. Basalt rock is used along railway tracks to stabilize the rails on which the heavy trains run. Basalt rock is weather-proof rock.